A neural network is a computer system designed to learn from data by recognizing patterns. It's inspired by the human brain structure, with billions of connected nerve cells called neurons. Similarly, a neural network uses many small computing units that connect and communicate to make decisions or predictions. Neural networks power technologies like facial recognition, language translation, voice assistants, and self-driving cars. Traditional computer programs follow fixed rules. For example, if X happens, do Y. However, many real-world problems lack clear rules, such as recognizing a cat, understanding speech, or detecting fraud. These tasks rely on patterns, not simple rules. Neural networks excel at detecting complex patterns in data, even those humans might miss. Imagine teaching a child to recognize dogs and cats. You don't explain shapes mathematically. Instead, you show examples. This is a dog. This is a cat. The child learns subtle differences over time. A neural network learns similarly. You provide many examples, it learns patterns, and then recognizes or predicts new cases. This ability to learn from experience is what makes neural networks powerful. A neural network is structured in layers: an input layer, hidden layers, and an output layer. The input layer takes in data, like pixels from an image or words from a sentence. Hidden layers perform the thinking by detecting patterns. More layers mean deeper reasoning, leading to the term deep learning. The output layer produces the final result, such as identifying cat or dog or a predicted price. Each layer has neurons, simple processing units that receive information, transform it, and pass it on. Neurons communicate via connections, each with a weight determining its influence on another neuron. During training, these weights are adjusted to improve accuracy, much like a child learns and improves. Training a neural network means improving its decision-making by feeding data, comparing outputs to correct answers, and adjusting connections to reduce errors. This process repeats thousands or millions of times, making the network highly skilled at pattern recognition and prediction. Consider wanting a computer to recognize handwritten numbers from 0 to 9. To train it, you show thousands of images of handwritten digits, each correctly labeled. The network analyzes shapes, curves, and stroke patterns, learning to differentiate a 3 from a 7 or 8. After training, it can identify a new handwritten number, even if unseen before. This is pattern recognition in action. Neural networks are ubiquitous today in voice assistants, social media, self-driving cars, healthcare, finance, and language translation. Voice assistants like Siri and Alexa use neural networks to understand speech and respond naturally. Platforms like Instagram and TikTok use neural networks to suggest content you might enjoy. Self-driving cars use neural networks to process camera and sensor data, detecting roads, obstacles, and pedestrians. In healthcare, they analyze medical scans, detect diseases, and assist with diagnoses. Banks employ neural networks to detect fraud and predict market behavior. Neural networks power translation services, converting speech or text across languages. Wherever decisions require pattern recognition, neural networks provide assistance. Advantages include learning complex patterns, improving over time, handling diverse data, and driving automation. They can understand relationships too complex for simple rules and improve with more data. Neural networks work with images, sound, text, and numbers, enabling intelligent decisions without human oversight. Limitations include requiring vast amounts of data, being computationally expensive, difficulty in explanation, and risk of bias. Performance improves with large datasets, but training large models demands powerful hardware. The reasoning behind decisions can be opaque, and biased training data may lead to skewed patterns. Despite these challenges, neural networks continue to advance rapidly. A neural network is a computer system that learns by detecting patterns in data. Inspired by the human brain, it uses connected units to recognize, classify, and predict information. Neural networks power much of today's AI, from voice assistants to medical diagnostics and self-driving cars. Simply put, a neural network learns from examples, improves, and makes intelligent decisions by recognizing patterns, much like the human brain.